Hey, fifth grade, let's go ahead and talk a little bit about what is the water cycle. So, what is the water cycle? You've probably heard the expression, it's raining cats and dogs. We're not talking about idioms today. Today, we're going to be talking about and looking at the different forms of precipitation. And also, you are going to be reporting on a text by sequencing ideas. So, let's talk about different forms of precipitation. So I've numbered this number 1, 2, 4, and 3. So up top, I want you to go ahead and on your whiteboard or just a piece of paper or on a scrap piece that you have or even in your science notebook, just number 1 through 4 and go ahead and write down what you think each of these is. Go ahead and pause the recording right now and then we will check it. Okay, so on precipitation up here, this top right corner, this is going to be, we have sleet. Sorry, I said top right. This is top left. So this is sleet on number 1. Number 2 is rain. Number 3 is snow. And number 4 is hail. So why are we talking about precipitation on the water cycle? Well, there is about 67.9%, so almost, so that about 70% of the Earth's surface is actually covered by water. And Earth is currently the only planet with a vast ocean of water on it. That's why the planet Earth is occasionally referred to as the water planet. And right here you can see, here is just kind of an image of Earth from outer space. And when I make this bigger and we look at it, you can kind of see like, man, here's North America. Yeah, there is a lot more ocean than there is land. So when we look at that and we think, man, how big our Earth is, which is pretty darn big, when we see how much water there is, it helps us to kind of keep this in perspective. So where is most of the Earth's waters found? And what are some of the other places on Earth where we have water located? So when we kind of think about it, we know most water on Earth is actually found in the ocean, but that's not where all the water on the Earth is. Some other places are, we have underground aquifers. We also have icebergs or ice caps. We have rivers and we have lakes. So we have more than one location where we have water located here on our planet. So since most of the Earth is water, so we've already established, okay, 67.9%, about 70% is water. Of that, 97% is salt water. Okay, so that means this little sliver right here is fresh water. This is what humans can drink. So when we compare what our planet is, a lot of it is unusable salt water by us, but then we also have fresh water. This helps us to understand the importance of fresh water here on Earth. So when we look at water that is in glaciers or even something called groundwater, this is going to be considered to be a freshwater source. Okay. So when we have water that's usually found in the atmosphere, that's going to be water vapor. So that's going to be our clouds. That's also going to be when we see like steam or when you have a cup and in the summer you have ice in it and then beads of water start to pool on the outside. That's going to be forms of water that are found in the atmosphere. Okay. So right here, when we're talking about like groundwater is water that the rain has gone through the ground and it is absorbed underground in different pockets. This is sometimes what we refer to as an underground aquifer This is usually where we get like well water, things like that. That's going to be underground forms of water. So within the water cycle, how does water move through the environment to get to where it is today? So as we are looking at this and we are kind of focusing on the water cycle, things that we know, what do we already know about how water moves? Well, we know that water is in the ocean. We know that things evaporate when we have the warming of different items. So that water will evaporate, go into the atmosphere as water vapor. Eventually it will cool and it'll fall in the form of rain, and that rain will fall and it'll go down through streams and rivers down below. So what prevents us from running out of water? Well, the water we drink today is the same water that has been on Earth for thousands of years. It continues to get recycled through the water cycle. We continue to drink the same water, to use the same water. We just have different water filtration systems on that water use today, on making sure that water is clean and safe for human consumption. So when we take a look at some different vocab in relation to water, we have something which is a river. And a river is a large natural stream of water that empties into an ocean, a lake, or another body of water. We have a glacier. This is a huge mass of ice that moves slowly over land. We have an ice cap. This is ice over a large area. Usually it's on the polar region of our planet, like Antarctica. Water can be found in places between rocks, like particles of sand or even pebbles. Sometimes it is in spaces of like solid rocks, and we call this groundwater. This is different than whole bodies of salt water that cover nearly 3/4 of our surface. That is the ocean. The water containing the salt is mostly found in the ocean, which is salt water. We have water containing very little bits of salt found in lakes. That's going to be fresh water. And a body that's usually freshwater is surrounded by like land is usually called a lake. So the water cycle is a global water recycling system. This is when the water evaporates from the Earth's surface, goes into the atmosphere, condenses, returns to the Earth's surface in precipitation, and usually it's to a new location. It doesn't just like stay in one spot. To be able to use it again is to be able to recycle it. So we're going to take a look at the water cycle. So go ahead and follow along with me. And what I would like you to do is jot down a few things that stand out to you of like, that's interesting. Or, I'm not sure I knew that. Here we go. The water cycle. Water particles in the water you drink today might have once flowed down the Mississippi River. Those same particles might have washed one of George Washington's shirts. They might have even been in a puddle lapped up by thirsty dinosaurs 1,000,000 years ago. Water is in constant motion on Earth. You can see water in motion in rushing streams, falling raindrops, and blowing snowflakes. But water is in motion in other places too. Water is flowing slowly through the soil. Water is drifting across the sky in clouds. Water is rising through the roots and the stems of plants. Water is in motion all over the world. So think about the Mississippi River for a moment. It flows all year long, year after year. Where does the water come from to keep the river flowing? The water flowing in the river is renewed all the time. Well, what does that mean? I know that we have new inside of it. When I add the prefix re means to do something again. So if it's renewed, you are doing something again. So it is recirculating. So rain and snow fall in and near the Mississippi River. Rain falling nearby soaks into the soil and runs into the river. The snow melts in the spring and it supplies water for the river during the summer. Rain and snow keep the Mississippi River flowing. The rain and snow in the Mississippi River are just a tiny part of the global system of water recycling. This system is called the water cycle. The big idea of the water cycle is this. Water evaporates from the Earth's surface and goes into the atmosphere. The water in the atmosphere moves to a new location. The water then returns to the Earth's surface in a new location. The new location gets a new supply of water. Here we go. So this is just kind of a very simple diagram showing this process. So water evaporates from the Earth's surface. The sun drives the water cycle. Energy from the sun falls onto the Earth's surface and changes liquid water into water vapor. The ocean is where most of the evaporation takes place, but water evaporates from lakes, rivers, soil, wet city streets, plants, animals, and wherever there is water. Water evaporates from all parts of Earth's surface, both water and land. Water vapor is made up of individual water particles. Water vapor enters the air and makes it moist. The moist air moves up in the atmosphere, and as the moist air rises, it cools. When the water vapor cools, it condenses. Water in the atmosphere changes from a gas to a liquid. Tiny droplets of liquid water form. It condenses the water, and it becomes visible as clouds, fog, and dew. But then the water sometimes falls back to the Earth's surface, because the wind blows clouds around, and clouds end up over mountains, forests, cities, deserts, and ocean. When clouds are full of condensed water, the water falls back to the Earth's surface as rain. If the temperature is really cold, the water will freeze and fall to Earth's surface as snow, sleet, or hail. So warm particles move through the water cycle at different speeds. They also follow different paths. For example, rain might soak into the soil. A particle might be taken in by plant roots. It might soon escape into the air through holes in plant leaves during a process called transpiration. If the air is cool, water might condense immediately as dew and fall back onto the soil. This very small water cycle that recycles the water back to its starting place quickly. The rain that lands on the roof of your school might flow to the ground. From there, it could enter a stream. After a long journey, it finds its way to the ocean. And there, the rainwater could re-enter the atmosphere as water vapor. By the time it condenses with millions of other particles to form a drop, the rainwater could be hundreds of kilometers away from where it started. When the particle returns to your surface, it could fall on the roof of a school in another state. This is an example of a large water cycle that moves water to a new location. So as we kind of look at this and review, okay, let's take a look at this short video clip I have for us on what is precipitation.
You might think that precipitation sounds like a bit of a dull subject, but we're not just talking about rain and drizzle we experience here in this country. It also includes extreme weather such as hailstorms and blizzards. In this film, we're going to be looking at those examples of extreme weather and finding out how rain, hail and snow are formed. All precipitation develops in clouds, and clouds are formed when water vapour in the atmosphere cools and condenses. As the water vapour condenses, it forms droplets, and if the cloud develops within or moves into a part of the atmosphere that is below freezing, then the droplets form ice crystals. The cooling process, which first forms clouds, can happen in many different ways. Air may be forced to rise along a warm front, and as it cools, deep layers of clouds can develop, sometimes reaching many thousands of metres all the way down to ground level. Air may also be forced to rise as a cold front approaches. In this instance, a wedge of cold, dense air pushes under the warm, moist air ahead of it, lifting it. Weather fronts tend to bring generally cloudy skies with relatively long spells of rain or drizzle, or sleet and snow at colder times of year. And finally, air may be forced to rise simply because it's heated by the Earth's surface and it convects. This is what we often see on a summer's day, with cumulus clouds building up and sometimes developing into towering cumulonimbus clouds. Then we can get very heavy rain and even hail. Let's look first at rain and drizzle. The only real difference between rain and drizzle is the size of the droplets. Drizzle is composed of very small droplets, 0.5 millimetre or less in diameter. The tiny droplets that fall from the cloud itself merge together or coalesce until the droplet size becomes large enough to fall from the cloud under its own weight. Even though drizzle is made up of small droplets, it can still produce some very poor weather. Heavy drizzle can seriously reduce visibility because the droplets are small and close together. In tropical climates, where deep clouds develop in warm air, this coalescing of droplets can produce quite heavy rain, but in our latitudes, anything more serious than drizzle usually starts off as ice crystals high in the atmosphere. When clouds build in air that's below freezing, we often get a mixture of ice crystals and supercooled water droplets. That is water which is just below freezing but hasn't yet turned to ice. It is this mix of ice crystals and supercooled droplets that is really the key to understanding how most precipitation forms. The ice crystals are able to grow rapidly where there is supercooled water nearby, because as soon as the supercooled water makes contact with the ice crystal, it immediately freezes. Then, as the crystals drift through the cloud, they connect with other ice crystals in a process called aggregation, and large snowflakes are formed. This process of aggregation can take place in any fairly deep cloud, whether it's formed in layers along a weather front or by the convective bubbling up process. If the air between the base of the cloud and the ground is no warmer than 2 degrees Celsius, then the snowflakes reach the ground intact. In warmer conditions, when the air beneath the cloud is above 2 degrees Celsius, then the snowflakes will melt and arrive on the ground as raindrops. This is the way in which almost all significant rain is produced in our latitudes. It starts as snow, but melts before it reaches the ground. The most energetic cloud types, and the ones that can produce really heavy rain, are driven by strong convection. As the air cools, the water vapour condenses into water droplets, forming clouds. As the cloud grows up through the atmosphere, it will soon pass the freezing level, and water droplets within the cloud will freeze and form ice crystals. That is called glaciation, and an anvil shape is typical of cumulonimbus or thunderhead clouds. The fuzzy edges of an anvil cloud show that there are ice crystals present, and the cloud has grown well beyond the freezing level. These ice crystals grow as other water droplets nearby freeze onto their surface, creating a coating of ice, and small hailstones are formed. Inside the cloud, there will be rising currents of warm air and some quite severe downdrafts of cold air. Small hailstones may fall through the cloud, helping to create the downdrafts. They can also be carried back up through the cloud by the rising currents of warm air. This can happen many times, with the hailstone melting and freezing and developing fresh coats of ice during its journey through the sub-zero part of the cloud. If you're brave enough to venture into a hailstorm, you can actually cut a hailstone in half and see how those layers of ice are built up like an onion as the hailstone travels up and down within the cloud. In really severe storms, that process is repeated so often and the currents of air are so strong that hailstones as big as golf balls can be supported. In really severe storms, hailstones as big as tennis balls have been recorded. The largest hailstone ever recorded in recent times came from Bangladesh in 1986 and measured a whopping 15 centimetres across. It weighed over a kilo. That's the same as a bag of sugar. Next time you're out in the rain, have a think about what's going on above your head and the journey those raindrops may have made from water vapour into cloud droplets, snow, maybe even hail, before falling to earth as rain. If you want to learn more about precipitation or anything to do with weather and climate, visit the Met Office website.
All right. So let's go ahead and head on in and take a look at our assignment over in Buzz. When we go into 5th grade science today, you're going to see that you have a recording on the different forms of precipitation because we have Teacher Summit on Thursday and Friday. So when I go into Module 9, down here on the different forms of precipitation, you're going to see that we have the lesson, we have some activities in the lesson, and then you are going to have a quiz when you get to the end over the lesson. So you're going to be learning about different forms of precipitation, As you go through, you're going to have a self-check on the different forms, trying to match them together. When you get to the last page, this is where it'll say like, hey, you have a quiz. But before you do, you have something called the Great Aqua Adventure. And I want you to take a look at this one right here with Sabrina with Crash Course Kids before you go in and you do your quiz today. All right, so good luck. You got this. Way to go, 5th grade.